Oh, hey, boys and girls. I didn't see you there. Sorry, I'm kind of sick as a dog right now, but just bear with me for this video. In this video, we're going to talk about how slope is used in math. But the first thing that we're going to do is talk about what a slope really is. Slope is a measure of how steep something is. So we use numbers to determine how steep a slope might be. Let's look at some real-world examples of what slope is and where we might see it. So for example, if any of you go skiing or snowboarding, the mountain is a slope. There's a steepness to it. Some mountains might be more steep than others, but it has some sort of steepness to it. The roof of your house is going to have some sort of slope that also measures how steep the roof might be. We see slope a lot in architecture. So for example, looking at the steps, some stairs are a little bit more steep than others, but they all still have some sort of slope. And then even on the roads, when we're going up and down mountains, over bridges, we go up and down because there is some sort of slope. Now in math, we use m as our variable to determine slope. But why? I have absolutely no idea. There's been a lot of research done on this. Why didn't they just use s to represent slope? Well, we use s to represent other variables in math. And a lot of mathematicians and people who have studied this think m for mountain, because mountains are the first thing that we think of when we think of slope. Or some people think, because it's the middle of the alphabet, that we're going to pick m to represent slope. But all you really need to remember is that m is represented by slope. So let's talk about slope in math. What slope is it determines the rate of change between any 2 points. And again, it is a measure of how steep a line might be. We have a couple different types of slope. The first type of slope is a positive slope. If I were to look at this line and read it from left to right, you'll notice the line goes up. That determines what we call a positive slope. On the contrary, if I look at this line here from left to right, you'll notice that the slope goes down. Therefore, that's what we call a negative slope. If you have a line that's horizontal, for example, your desk at home or your kitchen floor, that's what we call a zero slope. There's no steepness to it, therefore the slope is 0. Then we have vertical lines. If we have a graph that forms a vertical line, we call this as being undefined. Because the line goes up and down forever in both directions, we can't really define a slope. So that's what we call an undefined slope. So we're going to fill out the front part of your graphic organizer based on that information. So a positive slope is a slope that goes up from left to right. So you're going to write goes up. So let's draw an example of a positive slope. And just draw a line that goes in the up direction when reading from left to right. Now a negative slope goes down. When I read the graph from left to right, the line is going to go in a downward direction. A zero slope is going to be any horizontal line. So horizontal line looks something like this. So in that case, the slope is 0. And then a vertical slope, or I'm sorry, an undefined slope is going to be represented by a vertical slope. And in that case, the line is going to go up and down. Now going back to the presentation, let's talk about how to calculate slope. So looking at a slope, it's your change in y or your change in x. So basically looking at this line, to go from this point to this point, I have a change on my y-axis. Then to go from this point to this point, I have a change in my x. So we use something that's a little bit easier to understand called rise over run. So looking at this first line, I'm going to draw a line where both of these points might meet. I'm going to go up 1, and I'm going to go over 1, 2, 3. So we have something called rise over run, which is your change in y over your change in x. Now looking at this line, I'm seeing as I go left to right, it goes down. Therefore, it's a negative slope. Let's look at another example. Sometimes students like to use color coding. So my rise might be one color, and my run is going to be another color. My change in y is my rise. So I'm going to rise 1, 2, 3. And I'm going to run 1. Therefore, my slope is 3 over 1. And if I read it from left to right, I see it goes up. Therefore, it's a positive slope. So I'm going to leave it as is. Here's my next example. My change in y is my rise. My change in x is my run. I'm going to rise 1, 2, 3. And I'm going to run 1, 2. Therefore, my slope is 3 over 2. And if I look at the line, it goes down. Therefore, it's a negative slope. Let's look at one more example before our graphic organizer. Again, I have my change in y over my change in x. Oops, let me change the color for you. My rise is going to be 1, 2, 3. And my x is going to be 1, 2. Therefore, the slope of this line is 3 over 2. And because the line is going up, it's a positive slope. Now I want you to turn your graphical organizer over to the back. So rise means you go up or down, and I'll explain what the down is in another video. And run goes left to right. So right in the positive direction, and left would be in the negative direction. So looking at this graph, if you don't have colors at home, that's okay. You can just still use your pencil and highlight your rise over your run. I'm going to rise 2. And I'm going to run 1, 2, 3, 4. Now, because I went to the left, or if I look at my line and it's a negative slope, my slope has to be negative as well. And in this next example, I'm going to highlight my rise. And I'm going to highlight my run. Therefore, my slope is going to rise 1, 2, 3, 4, 5. And my run is 1, 2. The line goes up, therefore it's a positive slope, so I can just leave my slope as 5 over 2. All right, everyone, I hope you have a great evening, and I will see you tomorrow. I don't know why I just did that. Okay, good night.